All right, well, we're going to start this lesson off by learning how to identify how many solutions a specific polynomial is going to have just based on looking at the function equation itself. And so again, just to reiterate something that I've been saying for the last few chapters is that you just have to remember that a solution and a zero are the same thing. And then on top of that, a solution and a zero are the same thing as the x-intercepts. This is where the function is crossing the x-axis. And so it's very easy to look at a polynomial and tell how many times it's going to cross the x-axis, how many solutions or x-intercepts it's going to have. What you want to do is look at the function and identify the highest order term. And so in number one, the highest order, the highest degree is that x to the third. Okay, so this is a third degree polynomial. And so because it's a third degree polynomial, we know that it is going to cross the x-axis 3 times. So it's going to have 3 solutions, 3 zeros. Number two, it is in standard form as well, just like number one was. And so to identify how many that function is going to have, you're just looking at that first term, and it is of degree 6. So we know this is going to have 6 solutions or 6 zeros. If you look at 3, 3 is kind of almost in standard form. It's not set equal to 0, so you'd have to subtract 6. But that doesn't really concern us because we're only concerned with the highest order term, which in this case is a 7. And then over here, number 4, again, this is not in standard form in the least, but you're just looking for the highest exponent. And that will tell you that highest exponent, whatever that number is, like in this case is 5, that is the number of times it'll cross the x-axis. So that means it's got that number of solutions of that number of zeros. In 5 and 6, they want us to actually find all the zeros of the function. We've done this for the last few sections. It's not going to change. We know we're looking here in number 5 now, though. Now that we know how to tell how many zeros there will be, we know that we are going to be looking for 3 zeros. Okay, but they're not asking us just to identify how many. They want us to actually find them. So we're going to go through those steps to find those zeros. The best thing to do here is to follow the rule that we learned where we can take the factors of the constant. All right, in this case, that will be that 3, and place them over the factors of the lead coefficient. So we did this in the last section. This is no different. The factors of 3 are going to be plus minus 1, plus minus 3. The factors of our lead coefficient 1 are just plus minus 1. So this is very easy. If we're going to set up those ratios, it would be plus minus 1 over plus minus 1, which is just going to reduce down, of course, to plus or minus 1. And then the same thing here, plus or minus 3 over that plus or minus 1. I'm not going to take the time to show that and then reduce it. We're going to call it plus or minus 3. So here are our options. 3 of those are going to be zeros. So I'm going to try one of them using synthetic division. I might pick the wrong one the first time around, and that's okay. We'll see. I'm going to start with 1. Set up my rectangle for synthetic division, and then move through that algebra. All right, and I get a remainder of 0 here, so 1 is one of the factors, one of the solutions, okay? So x minus 1, I'm going to write my trinomial. My highest order here was a third degree. This is third degree, so this right here is going to be squared. We always lower it by 1. And then we have to look and see if x squared minus 2x minus 3 can be factored further. We're looking for factors of negative 3 that add to negative 2. That would be negative 3 and positive 1. And then drop this down here. set each of those equal to 0, and when we do that, we'll end up with those three solutions. So that checks out. We have 3 solutions, which is what we determined initially, and they all fall within these 4 options right here. Same thing with number 6. We can see here, though, that we're going to have 4 zeros because of this lead coefficient having that's the highest order exponent. So we're going to have 4 zeros. We will take the factors of this last term, which is that 48, and write those out. And there's going to be quite a few, actually. I probably didn't leave enough room. Plus or minus 3, plus or minus 16. I'm going to drop down right here. Let's see, plus or minus 12, and then plus or minus 6, and plus or minus 8. Now, all of these are going to be set over the lead coefficient of 1, and so I'm not going to write that out because it's just going to reduce down to what we have right here. So these right here are the possibilities, way more than 4. So they're obviously, most of these are not solutions, so we're going to just try one out first. I'm going to start with 1 like I typically do. Okay, and I can see this is not going to work out. This one is not does not have a remainder of 0, so 1 is not a factor. Let's try 2. All right, and this one works. Okay, so we end up with a 0 as our remainder. So 2 is one of the solutions. So we're going to write out the binomial with the trinomial. Now here, this is an x to the 4th term. So when we write out our lead coefficient, our lead term, it's going to be x to the 3rd. We're just dropping it down 1 degree from the original. And then we go through the rest of them like so. And so we end up with those two, a binomial and this trinomial. We're going to start, then I'm going to leave that x minus 2 on its own for a minute. We know that 2 is going to be a solution. We can see that. And I'm going to factor out the GCF right here, which is an x. That will give me something a little bit easier to deal with here. Now I have a quadratic that I can look for factors of negative 24 that add to negative 2. And that would be negative 6 and positive 4. I can't forget about this x right here, but I'm just going to write it at the beginning. I'm going to go, that's typically how we would write that. That way, now I know I have x equals 0. So that's why that's important not to forget that, because one of the solutions is 0. From here, I can see one of the solutions is positive 2, like we already stated, 6, and then negative 4 right here. So I end up with 4 zeros. It's a good sign because that's what I predicted. And all of those fall within these possibilities that we listed out here. Now moving down to the bottom of the page, they want us to write a polynomial function, f. So what that means is they just want us to write the final term, the final function calling the function f. So f of x, like in number 5 we just did, it was h of x. Number 7 here is g of x. They just want us to name it f. So we're going to write f of x equals, they say of least degree. So they want us to have this be the lead coefficient, and once we put it in standard form, the lead term have the least degree that's possible. All the coefficients be rational, the leading coefficient be 1, and the given zeros. So really the thing you need to focus in on here is that they have given us the zeros. So they've told us that our zeros are negative 7 and negative 4. So if our zeros, so that means when you take those binomials, you set them equal to 0 after you've factored, you end up with this right here. So this is like the last step that we just did up in 5 and number 6. Okay, so if these are our zeros, then we can kind of work backwards and say, well, if those are our zeros, then our the binomials that we multiplied together to get these zeros, these x's, would look like this. Okay, and all I'm doing there is I'm just pulling the 7 over, I'm adding 7 to both sides, so I'm getting like x plus 7 equals 0, and then x plus 4 on that other side would equal 0. So these two binomials are what we would need in order to get zeros of -7 and -4. We are literally working backwards from what we just did on 5 and 6. 5 and 6, they gave us the function. We had to factor to find the zeros. Now they've given us the zeros, and we're going to go backwards to find the actual function. So from here, we just need to FOIL. X squared, 7x plus 4x plus 28, and then simplify, and remember that we're calling it f of x. All right, so that's your final answer for number 11. All right, same thing on number 12, but now we have 3 zeros. So because we have 3 zeros, we know that our lead term, the highest degree on our lead term, is going to be 3. All right, so that's what we're looking for. If these are our zeros, the only way we can get those as zeros is if our binomials that we ended up with at the end of factoring would look something like this right here. Okay, so from there, now we can FOIL the first two or the last two. It doesn't actually matter, but I'm going to start with these first two. And that's eventually going to be multiplied by x minus 5, but I'm going to do some cleanup here just to make it easier. All right, and then I'm going to go through and multiply each of those terms in the binomial by each of the terms in the trinomial. A little bit more to keep track of here because it's not two binomials, so we don't have, it's not just FOIL. All right, and then I've got to go through and combine like terms. Minus 10, and again, they asked us to call this f of x. And so I'm just going to write that out there. There's your final answer for number 12. Now let's go ahead and look at number 14 as well because of those imaginary numbers there. I want to make sure it's not really any more complicated, but I want to be sure to do one of those with you as an example. Same idea here. They're 3 zeros, which means you're going to have an x to the third as your highest degree in your polynomial. In order to get those 3 zeros, though, we're going to have after factoring, these 3 binomials right here. All right, now this third one is really x minus that negative I, but those two, the minus sign and the negative sign, are going to cancel down to give me a positive. So that's how I'm getting this positive sign here. So we're just going to go through and do the multiplication on this. I'm actually going to combine FOIL, rather these two right here, just because of those imaginary numbers. I'm going to go ahead and do that. So if you can see here, here's my inner terms, my outer, which I know I did that out of order and according to FOIL, but you end up with the same thing in the end. These two terms right here, this I to the x, those two are going to cancel out, right? A positive and a negative will cancel out, which is good in this case. I'm going to drop that x minus 4 down, and then now right here, instead of saying x squared minus I squared, we know that I squared is -1. All right, so we really have a minus 1. And you have to go back to the last chapter when we learned that the square root of -1 equals I, and that I squared then in turn equals -1. Okay, so just going back to that concept that we haven't talked about in a few sections. All right, and so we end up with this right here. And then from there, you can see that we need to FOIL again. Okay, so we're going to FOIL these two out because remember, we're going backwards. We're trying to find the polynomial. So we're just going to keep working at it until we end up with the final polynomial. Okay. Looks right, I think, right there. And then, actually, and that's in standard form as well. So this is our final answer. However, they did ask us to name it F. So I'm just going to be picky right now and go and rewrite it again. Same answer. I'm not doing any more algebra. I'm just renaming it with that f of x in front of it. All right, now in number 18 and 19, they specifically want you to use a graphing calculator to graph that function first. And then they want you to use the zero or the what's called the root feature to approximate the real zeros of the function. So basically we're doing the same thing that we did on the front side of the worksheet, but I'm just going to show you now how you can also do that on the graphing calculator. So the first step then is to go to your y equals. And once you're at your y equals, you're going to put in the function. So that x cubed. So remember, you're coming up here to this key right here to grab the x, caret, and 3. Some of you have the newer calculator, and it's going to look a little bit different than mine. And minus that x squared has its own key right here, so I can just hit the square for that. And then minus the 5x plus 3. All right, so once I have done that, I'm going to go ahead and graph it. And my window looks good. I'm able to see where it's crossing the axis. And you can look over at that x cubed and see that I should be expecting it to cross 3 times for 3 zeros, for 3 solutions, for 3 x-intercepts. And that's what I see on my graph. So I feel good about my graph then. So now what I can do is go to my second button and the trace button. So that's actually really taking you to this calc up here. Okay, and the second and the trace will take you to what's above in orange on my calculator. It's possibly a different color on yours. And then you'll scroll down to it's either going to say 0 or it's going to say root. Okay, so the newer ones probably say 0. I know my TI-82 that I have at home actually says root on it. So either one, 0 or root, or it might say both. And so you're going to click on that. And once you have clicked on that, hit enter. And it's going to take you to a screen that looks like this. It talks about a left bound or possibly says a lower bound, either one. What that means is that you're going to trace over, you're going to hit your left arrow key until we get to the left side of the x-intercept. And I went a little bit further than I needed to. I want to get to the left side of this intercept right here. So that's my x-intercept. I want the lower bound, meaning the most negative bound out here. So I'm coming away. I'm going to go to the left side of it to some degree. It doesn't have to be far away from it, but a little bit away from it. So now it says right bound. I'm going to do the same thing, but I'm going to go a little bit further to the right of that x-intercept. So I'm going a little further positive on the x-axis, and then I'm going to hit enter. And now it says guess. So I'm going to come do the same thing, but I'm going to get as close to the x-intercept as I possibly can, which is, it's not letting me right on that intercept, but it let me close. So I'm going to stop there and I'm going to hit enter. And when I do that, I should end up with negative 2.08. You could round it to negative 2.09. And that's one of those zeros. Okay, so that's the leftmost 0. So you write that down on your worksheet. So we know so that's one of them. Now we're going to do the same thing for the next x-intercept, which is right here. So I'm going to kind of just trace over. I'm sorry, I've got to go back to second and trace. It's going to end it for you there, and you've got to go back, hit these buttons again, and then it's going to give you the prompt for the lower bound. All right, so I'm going to get a little bit closer to it than I am right now, and hit enter. All right, now it wants the right bound, so I'm going to go past that intercept a little bit more to the right of the x-intercept. And then it wants me to guess. And so I'm going to go as close as I can to the actual intercept and hit enter. And it calculates it at 0.571. So that's your second 0. All right, and we'll do it one more time. Second trace, 0 and enter. And then we're going to use the arrows to get this last x-intercept, which is right there. So anywhere to the left of it, enter. And then I'm going to go up to the right of it. And then I'm going to go back down. Probably that was a little more accurate, so I'm going to stop there, hit guess, and it calculates that third one at 2.51. And so that's what we expected. We expected 3. That's what we saw. That's what we calculated. And so then we can be done with number 18 and move on to 19. All right, so we will go to clear. To clear all this out right here. Actually, go to y equals instead. Y equals clear. And then I can type in my second equation at number 19. Pause this and start it back up once I have it in. All right, so once I've got it in, I'm going to hit graph. All right, and again, it looks like the window is pretty good. It might be a little bit harder to see these, so we probably could change the window a little bit to see if we can get it in a little bit closer, but it looks like we're pretty good. So we're going to hit second trace. And again, we're looking for 3 roots. So when we look at that graph again, we can see it kind of almost looks like there's only 2 roots because of how closely this is. It's just barely skimming the x-axis. So, but because we know this is a 3rd degree, we can make sure that we calculate 3 for 3 instead of just 2. So that's helpful. Left bound, and then go up and over just a bit, right bound, and then I'm going to come back over. And this is really challenging because it's so close to the x-axis. So I'm ending up with a 0 of negative 6.18, really negative 6 point, I'm sorry, negative 0.62. We could round that to. So make sure you write that down. All right, and then we'll do it again. Second trace. Second trace. 0. All right, and so I'm going to stay right there for my, actually I'm going to even bump it over a little bit more to the left, the left bound, just because we're so tight up against that x-axis. Come over to my right bound, try to get away from the x-axis as best I can, and then I'm going to go up and kind of guess about right there. All right, and so we end up with a 0 of negative 0.5. All right, and last time, second trace, 0. All right, and now we're looking at that last one over here to the far right, low bound, upper bound or right bound, depending on what your calculator says, and then get as close as I can. Those don't look a whole lot different to me, so I'm just going to go with that lower one. I end up with 1.62. All right, and that's it for those. Just don't forget to write those zeros down once you've calculated it. Otherwise, you've got to go, back through and do the trace function again. And so just make sure you write them down, each down as you get those calculated.